The ancient Greek poet Homer called olive oil liquid gold. And today, a little drizzle can still dazzle. Like fine wine, premium olive oil can bring a complexity of flavors to the table and create a real taste sensation. The roots of the olive tree stretch far into the past. For thousands of years, people have harvested its fruit and crushed it with stones to extract the precious yellow oil. In those early days, olive oil wasn't just used in food. It fueled lamps and was a medicinal ointment. Today's thriving olive groves are living proof that our appetite for olive oil hasn't waned. When green olives turn a violet red, they're ripe and ready for harvest. Workers shake the olives off the branches with vibrating rakes. The olives fall onto nets spread beneath the trees. They funnel the harvested olives into the factory. They fall down a chute into a large vat of pure water. A hose suctions the olives and water into a vibrating bin. It separates out leaves and twigs as the water drains away. The cleaned olives now bounce merrily on their way toward the crusher. A few centuries ago, the crusher was a donkey-powered apparatus. Today, a motor drives 1,300-pound granite wheels to grind the olives, pits and all, into a paste. Once the paste reaches the desired consistency, it's over to a computerized system that regulates the temperature of the paste as an auger mixes it. This separates the oil from the paste, making it easier to extract with this machine. Traditional extracting techniques involve spreading the paste on mats and then stacking them to press out the oil. This system is more high-tech. Rows of metal plates dip into the paste and the oil adheres to them. A spin in a centrifuge separates the residual paste from the oil. The result is virgin olive oil. A sample of every batch goes to the testing room, where there's a guy who has a nose for the job. He inhales the olive oil's aroma. Like a glass of fine wine, it should have a certain bouquet and should taste intensely fruity. If the olive oil makes the grade with this tester, the entire batch is ready for packaging. The packaging process is entirely automated, ensuring it's all done hygienically. A conveyor funnels these tins into line for a filling. A mechanized system then feeds the olive oil directly from big tanks into the tins. A measuring device controls the amount that goes into each one. At the next station, equipment spins and curls a metal disc around the lip of the container to put the bottom on the can. The conveyor flips the can around so it lands right side up, ready to pack. They package the premium grade oil in bottles. They use dark glass to protect the oil from the sun's ultraviolet light, which could cause olive oil to degrade and lose intensity. After an automated fill-up, they cap the threaded necks of the bottles. Machinery press fits and then screws the caps on for an airtight seal. Equipment then glues and applies the labels to the bottles. Preserved and protected, this olive oil is now on its way to the store shelf and ultimately to the table, where it's sure to kick up the flavor factor. The development of the forklift truck in Britain early uplifting event. It was during the First World War, and much of the country's male workforce was on the battlefront. So the forklift literally up where they left off to keep. The modern forklift has quite an extensive reach. That's because warehouses today expand up rather than out to stack more into a given space. Production starts with this welding robot. The robot uses computer smarts to fuse steel parts together to produce the truck body. Humans take over to weld together rails for the lift system's main frame. After a sleek paint job, the truck body is ready for the mechanics. An emergency switch goes on the front. It will allow the forklift operator to quickly cut the engine's power. Then, they assemble the lift's hydraulic system, beginning with the tank that holds the hydraulic fluid. They hook it up to the pump that provides the required pressure. They wire the pump so they can later connect it to the forklift's battery. They nudge the pump into its permanent position and bolt it to the floor of the truck. Wiring for the lights, horn, and lift sensors comes next. Then they slide a foot pedal into place. It both activates and brakes the forklift truck. At 7 horsepower, this engine may seem small, but it's enough to move the truck and a load of 2.2 tons safely. They check the oil and install a bracket for the vehicle control handle. The handle is then connected to a computerized system that operates both the vehicle and its hydraulic lift. They slide the steering wheel onto a shaft and make sure it's solidly attached. Production then hits a turning point as they power up the motor and check the steering wheel installation. They flush filtered oil through the hydraulic system that powers the lift. It's a cleansing process to ensure no dirt can compromise the hydraulics. They test the computerized controls for the lift and motor. With the hydraulic cylinders installed, they grease the mainframe above them. This makes it easier to slide the inner rails onto the frame, and later, the grease will also improve the function of this hydraulic lift. They thread chains through the main frame and its inner rails. These chains will work in conjunction with lift cylinders to elevate the load. They roll the forklift's carriage along grooves in the rail system. It's this carriage to which the forks and other attachments will be mounted. A special machine now maneuvers the lift into an upright position. Then they wheel in the completed truck. They call this a marriage because the truck and lift are getting hitched. They bolt the two sub-assemblies together from the inside of the empty battery compartment. They then temporarily connect the forklift to a battery in order to move it down the line. It's time for the forklift to undergo a little corporate branding with these company decals. They engrave a serial number onto a metal plate. It identifies the forklift for warranty purposes. They put a cover on the truck, and this forklift is ready to go to work. The forks in the battery will be installed on the worksite because they're often specific to the job. But one thing's for certain, this forklift is sure to carry a lot of weight in the workplace. Seamless rolled rings keep a lot of things running in our world, so we thought it was time to recognize their contribution. These wheels of steel are essential components of engines, power generators, and industrial machinery, to name just a few things. They keep things operating seamlessly. Ring starts with one of these solid steel billets. A hydraulically powered claw then takes the cut piece to a furnace fired to 2300 degrees Fahrenheit. That's hot enough to soften the steel for forging, but below its melting point. The steel turns bright yellow, which indicates that it's ready to be removed. The operator places it in a chamber where chains batter the ends to break off scale formed by the searing heat of the furnace. The claw then transfers it to an 1100-ton press. It squashes the steel slightly, causing the scale on the sides to crack and break off. Then it's over to a die. A worker places a bit of coal in the center of the hot steel chunk. The coal catches, generating a powder that lubricates the action of a 2,800-ton punch. The punch pierces the center of the steel and pushes it against the walls of the die, transforming the steel chunk into a donut. 30 feet away, the operator controls the gripper to lift out the donut. He then reactivates the punch to knock out the last bit of metal in the center hole. By now, the steel has cooled down quite a bit, so it's into another furnace to bring it back to forging temperature. Once it's yellow hot, this steel donut is ready to be transformed into a ring. A mandrel pokes up through the center. It stabilizes the donut as a conveyor slides it into position for ring rolling. The donut rotates, and rollers press against it to shape it into a thin, wide ring. Cone-shaped tools above and below also spin against it to establish the desired height. The hot steel is easily manipulated by the tools and stretches like putty. This process turns the donut into a ring, and that's why they call this ring rolling. The change is truly dramatic. A worker stamps a serial number onto the rim. Next, a tool drags the ring onto a conveyor, which takes it to a stacking device. The rings cool from yellow to orange. Soon, they'll be completely cooled and ready to head into another furnace, this time for heat treating. This tempering process relieves the stresses in the steel caused by all that rolling and forging. This makes the steel stronger and more resilient. Once this ring has been cooled and hardened, they position it on a turntable, relying on a special gauge to let them know it's on the mark. The ring revolves as a tool peels off that sooty-looking crust to reveal the glossy substructure. And they give the interior of some rings the same treatment. Now, these steel rings are ready to take their place as components in heavy equipment, power plants, and even train wheels. Because when it comes to their capabilities, they're definitely well-rounded. In a sport with steep challenges, proper footwear is a must. Early ski boots were made of leather, but when molded plastic boots came along in the late 1960s, they offered a big advantage: stiffness. Stiffer boots meant better control, and when you're heading downhill fast, control is definitely a good thing. The modern ski boot transfers the body's movements effectively to the skis. And a little high-tech can't hurt when you're trying to take your skiing skills to new heights. Transforming these plastic chips into a high-tech ski boot takes some planning. They design the boot on a computer and simulate the process of the chips being melted and molded into the shape. Like in the computer model, it will take just seconds to turn the chips into the outer shell of a ski boot. Machinery lowers boot forms into molds, which clamp together with a force of up to 550 tons. Pumps then inject the melted chips into the space between the mold